Greetings of peace and development to everybody. I will be a reporter for the topic lexical ambiguity. So let's start off with the first part. We have ambiguity. So ambiguity in language arises in a number of ways. There are ambiguities associated with the segmentation of speech. Consider the spoken phrases gray tape with gray tape, ice cream with ice cream. In normal speech, they sound the same. Some sentences have more than one acceptable syntactic interpretation. Here we focus on lexical ambiguity, both for visual and spoken words. Next part are the types of lexical ambiguity. Let's start off with homophones. Homophones are words with different meanings that sound the same. Next one is heterographic homophones. It sounds the same so that they are ambiguous when we hear them, but not when we see them written down. Examples are night and wait and wait. Next are homographs. Homographs are ambiguous when written down, and some of these may be disambiguated when pronounced. Lead as in dog lead and led the metal. Polysemous words which have multiple meanings. There are many examples of these in English Bang. Some words are also syntactically ambiguous. Bank can operate as a verb as well as a noun, as in, I wouldn't bank on it if I were you, or the plane is going to bank suddenly to one side. We also have other examples. For number 5, the fisherman put his catch on the bank. Number 6, the businessman put his money in the bank. Number 7, I got the mail and opened the letter. Number 8, the monk writing the manuscript took a long time to form each letter. Frazier and Rayner in 1990 distinguished between words with multiple meanings, where the meanings are unrelated. For example, the two meanings of bank or ball, and words with multiple senses, where the senses are related. For example, a film can be the physical reel or the whole thing that is projected on a screen or watched on television. So this is not the true dichotomy, as it is not always easy to decide whether a word has multiple meanings or senses. Most of the time, we are probably not even aware of the ambiguity of ambiguous words. Clearly, we have somehow used the context of the sentence to disambiguate, that is, to select the appropriate sense. The two main processing questions are, how do we resolve the ambiguity? That is, how do we use the appropriate meaning or reading? And what role does context play in this ambiguation and at what stage is it used? Early work on lexical ambiguity. Early research on lexical ambiguity used a variety of tasks to examine at what point we select the appropriate meaning of an ambiguous word. Most of these tasks were offline in the sense that they used indirect measures that tap processing some time after the ambiguity has been resolved. We also have early models of lexical ambiguity. We have the context-guided single reading lexical access model. We have people, as you can see in the PowerPoint presentation, that has to do with this. According to this model, the context somehow restricts the access process so that only the relevant meaning is ever accessed. One problem with this model is that it is unclear how context can provide such an immediate constraint. Next is ordered access model by Hagabo and Perfetti in 1975. All of the senses of a word are accessed in order of their individual meaning frequencies. For example, the writing instrument sense of pen is more frequent than the agricultural enclosure for animal sense. Each sense is then checked serially against the context to see if it is appropriate. Next is multiple access model. And according to this model, when an ambiguous word is encountered, all its senses are activated and the appropriate one is chosen when the context permits. Next part is the early experiments on processing lexical ambiguity. Early experiments appear to show that we routinely access all the meanings of ambiguous words. This interpretation is based on the premise that if an ambiguous word is harder to process according to some measure than a controlled and ambiguous word, even in a strongly biasing context, then this suggests that at some level the language processing system has detected the ambiguity. Mackay used a sentence completion task whereby participants have to complete an initial sentence fragment with an appropriate ending. Here we have 11. After taking the right turn at the intersection, I, so on and so forth. Or number 12, after taking the left turn at the intersection, I, so on and so forth. Participants take longer to complete 11 rather than 12 because of the ambiguity of the word right. It could mean right in the sense of the opposite of left or right in the sense of correct. This finding suggests that both senses are being considered, and the delay arises because the participant is making a choice. Consider sentences 13 and 14. 13. The farmer put his straw beside the machine. Number 14. The farmer put his hay beside the machine. Here, the context of farmer is strongly biasing towards the farmyard sense of straw rather than the sense of short drinking implement. Voss in 1970 used a technique called phony monitoring to show that ambiguous words take longer to process even when they are strongly biased by context. In this task, participants have to monitor spoken speech for a particular sound or phoneme and press a button when they detect it. In these sentences, the target is B. Participants are slower to detect the B in 13 than in 14. Presumably because they are slowed down by disambiguating the preceding word. Here we have Mailer Sequay and Carey in 1978 show that this effect disappears if the ambiguous words are properly controlled for length. It so happens that in English, ambiguous words tend to be shorter than non-ambiguous words. Lackner and Garrett, 1972, and Mackay in 1973, in the decotic or dichotic listening task, different messages are presented to the left and right ears. Participants are told to attend to one ear and ignore the other. Here we have here we have examples 15, 16, 17. Let's take a look at them. The spy out or the spy put out the torch as a signal to attack. The spy extinguished the torch in the window. The spy displayed the torch in the window. Afterwards, participants were asked to paraphrase the intended message. Their interpretation was affected by the unattended message that disambiguated the ambiguous phrase put out. On the other hand, Hogeboom and Perfetti in 1975 showed that the time taken to access meaning depends on frequency of use. They used an ambiguity detection task, which simply measures the time that participants take to detect the ambiguity. We have examples 18 and 19. The accountant filled his pen with ink. The farmer put the sheep in the pen. People are slow to detect ambiguity when the word occurs in its most frequent sense, 18 rather than 19, or rather than 19. This is because in 18, participants access the common reading of pen automatically, integrate it with the context, and afterwards have to reanalyze to detect the ambiguity. In 19, participants tried the most common sense of the word, failed to integrate it with the context, and then access the second sense. Hence, in this case, the ambiguity is detected in routine processing. Next, we have a person, I don't know how to say, in 1976, employed a successive lexical decision task in which participants see individual words presented in a stream and have to make lexical decisions to each word. Let's take a look at the three examples: 20, 21, 22. 20. Save bank money. 21. River bank money. 22. They bank money. The lexical decision time triads of words such as 20, 21, and 22 examples is the main experimental concern. The fastest reaction time to money was in 20, where the appropriate meaning of bank had been primed by the first word save. Reaction time was intermediate in control condition in 22, but slowest in example 21, where the incorrect sense had been primed. If all senses of bank had been automatically accessed when it was first encountered, then money should have been primed by the bank, whatever the first word. This result therefore supports selective access. Swiney's experiment in 1979 carried out such an experiment. He used a cross-modal priming technique in which participants have to respond to a visual lexical decision task while listening to correlated auditory material. We have example 23. Rumor had it that for years the government building had been plagued with problems. That man was not surprised when he found several bugs in the corner of his room. In example 23, the ambiguous word is bugs. The phrase spiders, roaches, and the other is a disambiguating context that strongly biases participants towards the insect sense of bugs, rather than the electronic sense. Only half the participants saw this strongly disambiguating sense. Next, let's go on to the next person who is has equally important or has equal importance with the others. I don't know how to say his name, but he made it in 1979. He performed a similar experiment based on a naming task rather than lexical decision. They used words that were syntactically ambiguous. For example, watch, which can be a verb or a noun. They found that both senses of the word were initially activated in sentences such as Boris began to watch. I'll repeat it again. Boris began to watch, and Boris looked at his watch. Again, the context independent meaning faded after about 200 ms. Hence, syntactic contents cannot constrain initial access either. Next are the research on lexical ambiguity. There is now agreement that when we encounter an ambiguous word, all meanings are activated and context is subsequently used to very quickly select the correct meaning. Recent research has used online techniques, primarily cross-model priming and eye movement measures, to refine these ideas. Research has focused on three main issues. First, what effect does the relative frequency of the different meanings of the ambiguous word have on processing? Second, what is the effect of presenting strong disambiguating context before the ambiguous word? Third, how does context affect the axis of semantic properties of words? Next are accessing selective properties of words. Tableau C used a cross-modal priming task to show that sentential context that specifically constrains a property of the prime word leads to selective facilitation. So look at the examples 31, 32, and 33. The little boy shuddered eating the lemon. The little boy shuddered eating the popsicle. The little boy rolled on the floor a lemon. She argued for a modified version of context dependency. Not all aspects of semantic, pragmatic context can constrain the search through the possible meanings, but semantic features constraining specific semantic properties can provide such constraints. For example, the context in the example 31 clearly suggests the sour property of lemon. Debussy observed facilitation when the target sour was presented visually in a lexical decision task immediately after the prime lemon relative both to the same context, but with a different noun in 32 and a different context with the same noun in 33. Let's have the evaluation of work on lexical ambiguity. Early on, there were two basic properties or approaches to how we eventually select the appropriate sense of ambiguous words. According to the autonomous view, we automatically access all the multiple senses of a word and use the context to select the appropriate reading. Semantic information context is then used to access the appropriate sense of the word. On the interactive view, the context enables selective access of the appropriate sense of the ambiguous words. So let's go on with the summary. It's very important to know the summary because this is a summary of what we have learned in this topic. Char! Word recognition is distinct from object and face recognition. Recognizing a word occurs when we uniquely access its representation in the mental lexicon. Eyes fixate on material that is being read for 200 to 250 ms, with movements between fixations called saccades. Lexical access is affected by repetition, frequency, age of acquisition, word length, the existence of similar words, the physical and semantic similarity of preceding items, and stimulus quality. Semantic priming is the facilitation of word recognition by prior presentation of an item related in meaning. We also have semantic priming has a fast, automatic, mandatory, facilita- facilitatory component and a slow attentional component that inhibits unexpected candidates. The lexical decision and naming tasks sometimes give different results, with lexical decision more prone to contamination by post-access process, such as response checking, and naming prone to contamination by the processes involved in assembling a word's pronunciation and recognizing visual words in page 189. Semantic priming has an automatic component based on association and an attentional component involving non-associative semantic relations. Some types of non-associative or associative semantic relations may give rise to automatic facilitation. Instrumental semantic priming, at least, is automatic. We have different things to ponder as well. Here they are. I just want you to take a glance of these very important sentences. I don't have to really read them all because I will still just give this to Mambakulya. So I don't have to read everything. Here they are. So I just want you to also remember these things. They're very important. Okay. So next, let's have lexical ambiguity, how important it is, and also the disambiguating context constraints that constrains the alternatives. That's it. We are done. So I hope you learned something from my speech or my report for today. Have a nice day, everybody. Doodles!